All right. All right, let me see what your question is. All right, so you had different quizzes, but everybody had a question that was similar to this one. So we need to get this under control, folks. This is important. Oh my God. So first of all, as soon as you put these pluses and minuses into the problem, then you can't be just picking pieces off and moving them. That doesn't work that way. So what you have to do instead, you can make this 1 over n cubed, but it stays in the numerator. So it's 1 over n cubed minus 4n, 6 plus 1 over n. Now that's a complex fraction. It's a big fraction with little fractions inside it. So we're going to clear those denominators out. So we'll multiply everything by n cubed. Some of you goofballs, excuse me, this is goofy. You multiplied the top by n cubed and the bottom by n. Can you multiply the top and bottom by different things? No. So you had the right idea. You knew you needed to get rid of the fractions, but you got to multiply by the same thing. So that'll be 1 minus 4n to the 4th over 6n cubed plus 1 n squared. Sorry. All right, so look okay to everybody? Now, there is a potential to be able to factor, and I know I can factor the top and the bottom, but since nothing cancels, I'm not going to do it. If something would cancel, then I would factor and cancel out, but nothing does. All right, let's do one more quiz question or homework question, something like that. Sydney?
Can you do homework 3.4 number, sorry, I just had it. This guy, actually homework 3.35.
3.3, number 5.
Yes, please.
That is a regression problem, so I would rather you come in and we'll work that out.
Okay.
You doesn't look like you answered the question.
Yeah, I did not figure it out.
Or you just put it over and
Oh, wait. Yeah.
okay, bring it on in, we'll look at it.
Okay.
All right, what?
Will we go over 5?
Oh, all right, so here's another one from a quiz. So you're given a couple of values. Totally made up values. Made up. And based on those values, we want to find the logarithm of the square root of 6. Okay? All right. So first of all, logarithms and radicals do not get along. So I'm going to think of this as 6 to the 1/2. And then I can take this out in front, so it's 1/2 log 6. Would you agree with that? Now, what's special about 6 in terms of what I was given? 6 is 3 times 2. So this is 1/2 the log of 3 times 2. Well, what happens when you take the logarithm of a product? What do you end up doing? Adding the logarithm. So that's going to be 1/2 the log of 3 plus the log of 2. So we just take those two numbers, add them together, cut it in half, and that's the answer. Okay? All right, one more, and then we're moving on. One more question from something that I handed back to you. Okay, all right, well then let's get back to our notes. I did put in my calculator, so I didn't know how to work. This is what, this is the equation I'm coming up with, which is this. Okay, so you just put it here, you just put it in 100,000. Everyone read the email that I sent you about next week's activities? And yep, math week, food drive, paper due, there's just a lot going on. It is. All right, so last time we were together doing this, we got one problem done, and that was 2A, Newton's law of cooling. So there's one more example there. Let's go ahead and do that since it's been a while since we did it. So you're not responsible for the formula, so I'll copy that down from the page before. Okay. A cup of coffee has cooled from 92 to 50 after 12 minutes in a room at 22. All right, so let's plug all that into our equation. So what goes where? We're looking at just that first sentence. So a cup of coffee has done this. All right, so what goes where? 92 is the original temperature of the thing. So this is gonna be 92, all right? What else? Where's the 50 go? No, 50, the temperature of the medium, what would that be? That's 22, that's what the room is, so this is 22. This is the temperature at a given time. So that right there is 50. If the given time is a 12, right? So we can solve that for K. So we'll subtract 22, and what is that, 28? And we can subtract those and get 70. Now what do? Divide, so we have 28 over 70 equals e to the negative 12k. Then we can natural log both sides. So the natural log of 28/70 equals negative 12k. So k is going to equal the natural log of our fraction divided by negative 12. Now, you got a number, right? That's type it in and get a number. That does not answer our question though, because our question says, how long will the cup take to cool to 30 degrees? So we're gonna go back and redo the whole problem. Now our temperature at time t is gonna be 30, and it's still 22, and it's still. But now the question is, how long will it take? Right? And we couldn't just do that to start, because like last time, we got too many variables in this equation, right? So we had to go through this in order to get our k value, which is on my calculator now. And now I can go about solving this one. So 8 equals 70 e to the negative kt. So 8/70 equals e to the negative kt. Are you keeping up here, guys? So my time is going to be ln 8/70 divided by negative k, but k is the number in my calculator. So ln 8/70 divided by negative second answer. I got 28.4 minutes. Did you?
Yes.
This Sturshagio is a Newton's Law cooling fan. It isn't all that special to me, but he really likes it. So it wouldn't surprise me one bit if we had a test or quiz question like that. Give you the formula, but you gotta know what goes where, right? You have to know what goes where. What?
So the 8 equals 70 e to the, oh, wait. We did the equation 2 times.
You have to do it twice. Because to answer the question that's asked, you have to do K. So you have to solve it one time to get K, and then you can solve for what's your Okay, now we've got, now there's a little conversation about orders of magnitude. And you're very familiar with that. That's just how many powers of 10 things are different by. So an example they give you, a kilometer is 3 orders of magnitude longer than a meter, because a kilometer is 1,000 meters and 1,000 is 10 to the third. So all powers of 10, all powers of 10. A dollar is 2 orders of magnitude greater than a penny. Okay, so that's what that means. Now, there are a couple of things where powers of 10, scientific notation, basically, are hugely important. One of them is the Richter scale, and one of them is pH from chemistry. We don't have time to spend a bunch of time on this, but since you all take chemistry or have taken chemistry, let's do a problem like on page 44, letter D, just to kind of see, actually we better do B because it kind of explains up there. So let's do B at the top of the page and just see how easy this is. It really, really is easy. You aren't responsible for memorizing this. You may have had to do it in chemistry class, I don't know. But let's just see how we use the math and the logarithms in a situation. It says pH is negative log, where that is the hydrogen ion concentration of the solution. Okay, I hate the chemistry. I'm reading what I'm writing, I have no clue what's going on, I'm just writing down what it says. If vinegar has a pH of 24, okay, so the pH of vinegar is 24.
It's 2.4.
2.4. Oh yeah, it's gotta be between 1 and 10. Even I know that, yeah. Thank you. So pH is 2.4, and baking soda has a pH of 8.4. How many more times acidic is the vinegar? Okay. Would you agree that I can divide both sides of this equation by a negative? Right? And now, since this is a common logarithm, the base is 10, I can rewrite this as that ion concentration thing is 10 to the negative 0.24, right? Loop-de-loo, log roll, whatever he calls it, that's what's happening here, 10 to this equals that. And we do the same thing over here. So this one would be 10 to the negative 8.4. Now, this one was the vinegar, and this one was the baking soda. Now, would you agree that this exponent is 6 more than that exponent? So if I'm adding 6 to this exponent. To get that one, I would have to add 6, right? But since that's an exponent, wouldn't that be the same as negative 2.4 times 10 to the 6th?
Would it be 10 to the negative 6?
Oh, yeah. Would you agree with that? Actually, I should be going the other direction. I'm gonna change this one into that one. So 10 to the negative 8.4 plus 10 to the 6th will give me my vinegar concentration, or not plus, times. Is that right? Yeah, because I need to, this is the one I need to know how many more times he is bigger. So how many times more acidic is he?
6.
No, not 6 times, 10 to the 6 times, right? 10 to the 6 times. So he's, what is that? Is that a million? So he's 1,000,000 times more acidic. 10 to the 6. Because, remember, when the exponents are adding, so the 6 is the exponent, but in terms of the numbers, you are multiplying by 10 to that power. So how many more times is this than this? Times 10 to the 6th. Times 10 to the 6th. If we have time to come back and look at a couple earthquake problems, we will, but we really need to get, to these financial problems. Alright, so here's the situation. If you look at the next page of your notes, 3.6, so I want you to do 3.5. I'll look at it real quick. Oh, I gave you my 3.5 will be due on Tuesday. I wanna make sure there's no, there's no, earthquake problems on it, but there is a Newton's law of cooling on it. So 3.5 will be due on Tuesday. And now we're gonna start 3.6. 3.6 has a bunch of formulas, some of which you have used before and some of which you haven't. So I am going to write down one of these formulas. And I'm gonna try not to, because I'm gonna try to stick with what's on the sheet here. But I sometimes use N's here instead of K's. Do you remember this formula from last year?
Yeah.
Were those N's or K's last year? N's, I love it. Let's use N's then, if that's what you're used to. I'm gonna use N's. All right, this is the compound interest formula. So, if you are, we're gonna do some problems here. If we have to figure out how much money's in the account after 3 years, if we compound quarterly, this is your formula. Compound monthly, this is your formula. Compound daily, this is the formula for compounding interest a certain number of times a year, however many that is. So A, you'll recall, stands for the end amount. P is the principal or the beginning amount. That's how much you invest. That's a 1. This is your interest rate, but you must enter it as a decimal. So the problem will always say something like 7%, but you have to put that in as 0.07. And there are 2 of them in the formula. Anytime a letter is in a formula more than once, it always stands for the same thing. So N, both of these N's, stand for the number of times per year that you compound. So in a compound quarterly situation, N is 4. Monthly, it would be 12. And then T is the time in years. Okay? Alright, now be careful because T is in years. So if you're doing this for 6 months, then you're gonna have to let T be 1/2. Right, so just remember that is this formula, the money formulas times in years. Okay, now, right under that is another formula that I know you've seen before. And this is the formula for compounding continuously. Continuously. So if the problem says quarterly, monthly, X times a year, this is your formula. If it says your interest is being compounded continuously, and that word will be in there, compounded continuously, then this is your formula. A and P stand for the same thing, R stands for the same thing, T stands for the same thing. Just have your little E in there. That's your Euler's constant, that's your E. Okay? So, they also include on the page the formula at the top that says interest calculated at the end of each year. So I want you to not worry about that so much. I want you to look at this formula, which you already have used, and let's suppose we're compounding annually. So at the end of every year, once a year. Well, what will this look like if n is 1? If n is 1, won't it look like 1 plus r to the t? Which is the formula they have at the top, only they use n for years, we've been using t for years. So this isn't a separate formula. They listed it separately, but that's what happens if you only compound once a year, at the end of every year. Okay, so let's not sweat that because it's really just a version of this one. These are the two that we really need to know by heart. We're gonna use those other ones, future value and present value, but you'll never have to memorize those, we'll give those to you. Let's see how this works. Number 1, suppose she invests $500 at 7% interest compounded annually. Find the investment 10 years later. So I'm focusing all my energy on these two formulas. These are the ones I have to memorize. So compounded annually means 1 time a year. So I want to know how much I'm going to end up with if I put in $500 at 7% interest, compounded annually for 10 years. So I am using this formula. Do all my numbers make sense to you there? So it's just a matter of typing it in and getting your answer. I got $983.58, did you?
Yes.
We're always gonna round our money problems off to the nearest cent. Pretty easy? Test? Find about, an interest compounded annually. What does annually mean, Tess? Once a year, right? All right, now we have Roberto. Roberto is investing $500 at 9% compounded monthly. Find the value of his investment 5 years later. Well, how much is it going to be worth if we invest $500 at 9% compounded monthly for 5 years? Does that make sense to everybody? You gotta be able to plug the numbers in. Everybody got those plugged in? I'm gonna go ahead and make this a 60. It's easier for me on my calculator, because I'm an old calculator. What'd you get? How much money does Roberto have?
$782.
782.84, perfect, beautiful, beautiful, beautiful. All right, those seem pretty easy. Let's look at number 3. Judy is gonna invest $500 at 9% compounded monthly. How long will it take for her investment to grow to 3,000? So make sure you're good with all those numbers and those spots. All right, this one's a little tougher. What are we gonna have to do? Divide first, so is that 6? That's nice. All right, now what?
Find that number.
If you wanna go ahead and figure out what that is, I'm okay, but don't round it off. Don't round it off, okay, so I never do it, I just wait till the end. But if it comes out nice, go ahead, great. But I just leave it, what am I looking for? I'm looking for T. So T's up here. What am I gonna have to do? I'm gonna have to log it. And as soon as I log it, then the 12T, both of them, 12 and T, are coming off. Now, I ultimately want to know what T is. Would you agree with me? So to make that happen, I'm going to have to take the log of 6 and divide it by 12, right? And then I'm also going to have to divide by this whole thing right here.
Can you do that at once?
Now, you can do it at once, but you gotta make sure it's in parentheses, because otherwise the calculator will divide and then multiply. You need to tell it to divide by both things. So I do it separately, but you can do it. Let's see what the answer is, just make sure you're getting this answer.
Wait, couldn't you also do log 6 divided by the log of 1 plus that number right there?
And then divide by 12?
Yeah.
Yeah.
Okay.
That's what I said. Yeah, order doesn't matter, because it's a multiplication type problem, so. All right, well, I was talking, I got 19.98.
Yeah.
So as long as you're getting 19.98 years, you are good to go. Whatever you're doing is good.
I didn't get that. I didn't get that. .001.
Then overshoot.
All right, number 4. Stephen has $500 to invest. What annual rate, compounded quarterly, is required to double his money in 10 years? So if I'm doubling my money, I'm gonna end up with 1,000? Are you gonna use logarithms on this problem?
No.
We're gonna divide by 500, so that's gonna be 2 equals 1 plus r over 4 to the 40th. How am I going to get r? I need to get r. I'm gonna raise both sides. I gotta get rid of that exponent. So if that were a squared, wouldn't you just square root both sides? Well, it's a 40th. So you can either 40th root both sides, Or, I like Peter's suggestion a lot, personally. I'm gonna raise everything to the 1/40th. Will that accomplish the same thing? So on your calculator, if you want a 40th root, if you want to do this, the 40th root of 2, you're gonna press 40, then math, then click down to the generic, you gotta press 40 first, then you click down to the one that looks like this, and put in 2, and the 40th root is 1.017, blah, 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 which is the same if you take 2 raised to the 1 divided by 40 power, you get exactly the same thing. So either way. So once we do that, then this is all we have left. So we subtract 1 and times by 4. And your interest rate looks like it's 6.99%. Now, first of all, make sure everybody got that. Everybody get that? Now, this is the interest rate that was required to double an investment of $500 in 10 years, compounded quarterly, right? What if this guy had started out with, I don't know, $5,000? Then the double would have been 10,000, right? Would that change anything?
It would make
No, it wouldn't make a difference, because first step is division, right? And if this is double that, then this is gonna be a 2 period. So this isn't the interest rate, well it is, but it's not only the interest rate required to double $500. This is the interest rate that will double any investment in 10 years compounded quarterly. Any investment will double at that interest rate compounded quarterly in 10 years. See that because the math? Start with 2 equals, yep. So do you hear what Chris said? Chris says, okay, great, Miss Ford. Then I could have started with this. Yep. Exactly right, doesn't matter, as long as this is double that. All right. All right, now, number 5, this is compounded continuously. Do you see that? Which means that's our PERT formula. All right, so we're compounding continuously. She invests $100 at an interest rate of 8%. Okay, we're not gonna do all these individual problems. Let's do 6 years. Let's do 6 years. They want you to do 1 year, 2 years, 3 years. We're not gonna do that. Let's just pick a number. We'll do 6 years. How much will she have? Oops. I don't know why that equals is there. How much will she have if she invests $100 at 8% compounded continuously? Do we need logarithms? No way. Second ln 0.08 times 6. Did you get $161.61? And obviously, if we were doing it for 5 years, you would just make that a 5 and so on. Right? Easy. 6. Would you agree that, first of all, maybe I better back up. Does everyone understand what compound interest means? What does that mean? We say we're compounding interest. What does that mean? You know?
You need to get interest on the interest
On
that
the
you're.
interest on the interest, that's
Yeah.
right. So, if I invest $100 and it is compounded annually, then at the end of the year, they put in my interest, right? And that's it. And then the next year, I get interest on my original investment plus whatever they gave me, right? That's compounded annually. Well, if you do that quarterly, then after 3 months, the bank gives me a little bit of interest. And then the next 3 months, I'm earning interest on that little bit of interest too. So does it make sense to you that the more times we compound, the faster our money grows? Now, it's not a huge difference, especially with today's interest rates. Like, your savings account isn't earning very much interest right now. But on the, if you have a CD that gets a bigger interest, the more times they compound that, that's gonna be a good deal for you. Well, what this means is your annual percentage yield means, all right, let's just figure out, Ursula invests $2,000 at 0.0515 compounded quarterly. Now, let's leave it in there for a year, because APY means annual percentage yield. So let's just leave it in there for a year, and let's figure out how much she has. How much does she have? Well, that's easy. We don't need anything fancy. We can figure that out. What'd you come up with? How much will she have at the end of the year?
2105.01.
Oh, geez, just a second. Yeah, I didn't get that, but that's because I pressed the wrong button. So $2,105.01, basically. Is that what you said? Okay. Now, annual percentage yield is how much interest, what was her actual interest rate on that money? Now, I know the bank said they're giving her 0.0515, but compounded quarterly, the annual rate would actually be a little bit higher. Do you see what I'm saying? Because this is earning interest on interest. So the amount grew a little faster than it normally would have. So we're gonna go back and we're gonna say, or we're gonna figure out, what would the interest rate have been if it was annual interest, just once a year? So we know this is what she ended up with. We know that's what she started with. We now are talking about just annual interest, compounded annually. So N is 1, T is 1. We're doing it for 1 year. So let's figure out what that is. So we need to subtract 2,000, or divide by 2,000. I'm getting ahead of myself. So then I got this number. So don't I just subtract 1? And my interest rate is 0.0525 or 5.25%, which is higher than what the bank told her she was getting, because that compounding increased her yield. So this is how much she actually got after a year, which would be the same as if the bank had given her 5.25 compounded annually. So this is her annual percentage yield right here. This is, basically, she's getting 5.25%. Even though she started out with that. So, you took whatever they gave her, figured out how much she had, and then converted that to a one-time-a-year compounding.
Oh, I know this one's not like, it's not, compounded continuously if we're like trying to find the annual percentage yield, but when something is compounded continuously, what does that mean? Like every day?
That means not every day, it means every second of every day. It is the maximum growth that can happen. So that formula is what we call the natural growth formula, because I want you to think about your own self, okay? When you were a child, do you know how much you weighed when you were born?
7 or 8 pounds.
Okay, let's just say she weighed 7 pounds when she was born. And after a week, you go back to the doctor for your week checkup, right? And let's say at that point you weighed 7.5 pounds. Did you go from 7 to 7.5 in one step?
No.
What happened? You went from 7 to 7.5 on a continuum. You were growing constantly, but every little bitty bit was covered that way. That's what's happening in this formula. So later on, not today, but next time, we will look at some populations. We'll be looking at growth, population growth. We'll be looking at some radioactive decay. Those are natural growth problems, right? You don't just go from 18,000 people to 30,000 people like that, right? You gotta go through all the steps in between. It's continuum. So that's what that means.
Okay.
How does E relate to that?
It goes back to the definition of E, which is in your packet there. Research it, it's fascinating. All right. Now, I want you to look at number 7. Quick on, you gotta get this one problem done. Number 7. I want you to tell me what is different about problem number 7. Okay, so all of the problems we've done so far, I walked down to the bank, or Roberto, somebody walked down to the bank with their $500, handed it to the bank, and then went away, and came back 10 years later and said, okay, how much do I have in my account? So it was a one-time deposit. Go down to the bank, deposit $8,000, come back 2 years later and see how much you have. This problem says, we're going down to the bank every 3 months, every quarter. So this is a problem like your parents are saving for your college. Every month or whatever, they're putting money into an account and hoping it grows to pay for your exorbitant college expenses. Or they're saving for their retirement. Every month, they're making a deposit, or every paycheck, they're making a deposit. These formulas, the ones that involve payments, are your future value and present value formulas. So the future value formula, and we gotta talk about the difference between these. This is the future value formula. You do not need to memorize it, but we gotta talk about what all these things mean. And then the present value. Formula, all right? We're probably not gonna get this problem done, but we'll at least be ready to do it next time. Now, make sure this is solidified in your head. You've got the formulas you've memorized. And these two formulas involve a one-time deposit. Okay, a beginning value. If payments are involved in any way, shape, or form, then those don't work. We're not doing those. We're doing these. R is the amount of the payment. That is the payment amount. I is the interest rate divided by the number of times a year we're compounding, or number of times a year we're going in, making a payment. So if it's monthly, making a payment every month, N is the total number of payments. So if your parents started out when you were born and they made a payment into your account 4 times a year, that would be, and you're now 18, that would be 72. Okay, 4 payments a year over 18 years. And that's a 1. Everything is exactly the same in this formula, but be careful, that exponent is negative. So if you're making 72 payments, that would be negative 72. All right, how do I know which of these 2 formulas to use? Because they both involve payments over a period of time. There are 2 situations where you make payments in your life. You either pay into your retirement account, saving for the future, or you have a car payment right now, in the present, you owe $5,000 for a car, and you're making a payment every month for that to go down, right? If you are saving for the future, if you are saving to accumulate, then you're using this one. If you are making payments to pay something off, like your house payment, your car payment, your student loan payment, if you are paying something off, you use present value. Real quick, when I make it, well, yeah, let's finish the problem. For problem number 7, which one am I using? Emily is saving, wants to know the value of her annuity in 20 years. Which one? Future value. So that would look like this. We want to know what is the future value. My payment amount is 500. The interest rate is 7.88 compounded quarterly. So 1 plus 0.0788 divided by 4. Now what's my exponent gonna be?
Why is it divided?
Quarterly.
Compounded quarterly. Quarterly means 4 times a year, right? And we're doing it for how many years? 20, so my exponent is 80 minus my 1. And my denominator, that's the same I as I had before, so it's 0.0788 divided by 4. Now, are you gonna need logarithms for that?
Nope.
No, that's a straight type-in problem. I do wanna caution you though, you can type this in, your calculator will handle this, but when you go to divide by that, you've gotta have that in parentheses, okay? Because you wanna divide by that fraction, so make sure you put it in parentheses. All right, let's look on 3.5, get that ready to go.